Now we are going to see about pitfalls in relational database. Here, common pitfalls in relational database designs includes data redundancy, poor normalization. It leads to anomalies, inflexible design, and security oversights, and neglecting the data types and constraints, all of which can lead to inconsistency, performance issue, and maintainability problems. Here in this relational database are widely used in modern software application for storing and managing data. However, designing a good schema that represents the data accurately and effectively is a challenging task. In this presentation, we will be seeing about the pitfalls in the relational database design as we have discussed, and how to decompose a bad schema, and what is a functional dependency, and how we are using those functional dependency to improve it. Here, first one is the pitfalls coming to data redundancy. Here, storing the same data in multiple places can lead to inconsistency and inefficiency, and it leads to maintenance problem and many other problems. Redundancy can help if waste the time of the users, and when you are trying to add or copy a data that are not being reflected in other copies, all these things comes under redundant data. Then next one is inconsistency. Here inconsistency refers to the data when different parts of database hold different versions of the same data. And third comes to inefficiency. Here inefficiency is due to lack of planning or over normalization, or it can be a rigid schema. Suppose if you are designing a database with a very specific structure, and it might be difficult to accommodate the new data type or changes in the business requirements. This is what the inefficiency. Then next one is complexity. Here the complex database schema can be difficult to understand and maintaining, leading to errors and efficiency. Here, and more than this, neglecting data types and constraints like improper data types, null values, lack of constraints, all these things are few drawbacks or few pitfalls in your relational database design. Apart from that, naming constraints. You are not maintaining a consistent naming conventions, which makes the database difficult to understand and navigate. Next one is decomposing a bad schema. What we come to say bad schema? When do we say it as bad schema? It is in a database schema that suffers from common design problems that can lead to issues such as data redundancy, inconsistency, and inefficiency. This decomposing a bad schema is how we have to overcome is using this normalization techniques. Now here we will be first seeing some common examples like how what is a bad schema, that is including a table with duplicate data or table with many null values, and here redundancy, the storing of same data multiple times, and when you are trying to insert, update, or delete something, some data, not something, data, and not following the proper normalization principles, which we'll be seeing in the upcoming sessions. And these are the things which we come to our knowledge when it is a bad schema. Therefore, it is essential to design a good schema that will be accurately representing the data, that is being efficient and minimizing the redundancy and maintaining the data integrity. And here it will minimize the anomalies too. So how we have to decompose the data using the normalization. Then these are the common problems in bad schema: redundancy, inconsistency, inefficiency, and anomalies. And what are the decomposition process is identifying the functional dependency, how we can reduce the data redundancy, how we can minimize the anomalies, and evaluating the trade-off and improving the data integrity. That is, normalization will be helping us to ensure that the data is consistent and accurate by enforcing the relationship between the tables. How? By using the primary and foreign key. And